All right, this is lessons 2.4 to 2.5 in pre-algebra. We're going to combine 2 and 4 and 2.5. I am going to explain to you how it is that we are going to solve equations from now until you're out of this school, because I have you next year too. All right, here we go. So you're paying close attention, all right? Here's the deal. What's the difference between this? This. What is this called, by the way? Just 3x plus 1. What would you call that? That's a variable expression. We just dealt with that last lesson, right? That's a variable expression. What's the difference between that and this? What is it now? This is an equation, right? This is now an equation. What makes something an equation is this. If you have a variable and you have an equal sign, that's an equation. Does that make sense? Here's the important thing to know about this. Here's the thing. A lot of people don't know this. That equal sign right there, this equal sign right here, that guy, he is not asking you if something is equal. That equal sign is telling you that this over here and this over here are equal. They are equal, right? An equal sign is telling you that it's equal. If I have, 4 plus, this is kindergarten stuff, equals 6, even there, that equal sign, all you're doing is trying to find out the variable. What's the variable in this guy right here? No, what's the variable? The box is the variable, right? The box is the variable. In kindergarten, you were doing algebra. 4 plus what equals 6? Now, here's the thing. So that equal sign is telling you that things are equal. What I want you to do is this. We're going to pretend like this guy right here, that equal sign is the foundation of a balance. You guys know what a balance is? You ever seen one of these? Where it goes like this, and then you've got your little, the little scale, right? A balance, a scale. And on that scale, it's balanced. That equal sign is telling you that it's balanced, right? The rules are this. You have to keep this scale balanced. You've got to keep this balance balanced. You are never allowed to get it unbalanced, ever. Which means that, here's the deal. Let's imagine that I actually have a balance right here, okay? And I've got 6 rocks on one side of the balance, and I have 6 rocks on the other side of the balance. Let's just pretend that, right? We're all envisioning I've got a balance here, right? 6 rocks on one, 6 rocks on the other, and it's sitting there perfectly balanced. If I took one rock off on one side, if I took a rock off over here, what would happen? It would go, that's no good, right? So if I want to take off one rock over here, what do I have to do in order to balance this thing? I have to take off a rock over here. Whatever I do, okay, well, hold on. What about this? What if I have 6 rocks on each side again, and I want to double the amount of rocks on this side? If I just double the amount of rocks on this side, what would happen? Right? Okay, so what would I have to do? If I want to double the rocks on this side, what would I have to do? I would have to double the rocks on this side, right? Does that make sense? And then it would stay balanced. No matter what I do in an equation, as long as I do it to both sides, we're okay. If I want to add 1,000,000 rocks to this side, that's totally fine, as long as I add 1,000,000 rocks to the other side. Does that make sense? If I want to subtract 17.6 rocks from over here, that's okay, as long as I subtract 17.6 rocks from over here. Does that make sense? No matter what you do, as long as you do it to both sides, you're okay. Now, you're not just going to want to randomly add 1,000,000 rocks to this, and you're going to want to do things to solve this baby, right? But you have to understand that that's the rule. Whatever you do to one side, you have to do the exact same thing to the other. Now, here's the other thing about equations, is that almost always what you're doing is you're going to try to solve for the variable, okay? solve for the variable. Just like this, when I had 4 plus the box equals 6, you all knew what to do here. You all know that, oh, what's the answer? I'd say, what's the answer? And you'd say 2. Now, technically, to say what's the answer here, that doesn't make any sense. To say what's the answer. This is telling you, right, could be 6, it could be... What you need to say, what in kindergarten, what they should say is solve for box. Now, they wouldn't say that in kindergarten because that would be confusing, but that's what they're really doing. You're trying to figure out what's the unknown. The variable is the unknown, right? What we do know is that this and this are the same. They're identical, right? That's what the equal sign is telling you. The equal sign tells you that this and this are the same. So, in this situation, on this equation, I actually need to solve for what? X. I'm solving for X. If that wasn't an X and this was a M, if this was an M, then I would be solving for M, right? I'm solving for the variable. I'm solving for the unknown. I know that this and this are equal. That's not what I'm trying to figure out. I got to figure out what the unknown is. Make sense? Now, I have a question. If I have this, 4 plus X, and I was to ask you, okay, what is X equal to here? It could be anything, right? Exactly. You don't know. X is an unknown, right? And it could be anything. Oh, but if I go equals 6, now can you tell me what X is equal to? You know it's 2, right? That's a kindergarten question. And that's the types of questions we're going to be doing today. Yay. I just have to show you how to do the really simple ones so that when we get to ones that aren't so simple, you still know how to do it. Does that make sense? Okay, so here's the deal. Let me tell you the story. I have a story to tell you. Here it is. We'll do a simple one here. We're going to go X plus, well, we'll do the simple one. We'll go 4 plus... No, we'll do an easier. X plus 4 equals 6. A simple one. Here's the deal. This is what we do. Each equation, I need you to think of as a duplex. What's a duplex? What's a duplex? My dad owns a duplex. It's a structure. It's a house that is split into 2 houses, right? Does that make sense? It's a single building that has 2 residences in it. Does that make sense? It's a single building that has a shared wall. It would be like that me and Mrs. Clark are in a duplex because we share that wall right there. Does that make sense? 2 different ways in, but we share a wall. This would be a duplex. My dad owns a duplex, right? One of them's a 2-bedroom, 1 bath. The other one's a 1-bedroom, 1 bath. They share a wall, but they're in separate residences. Make sense? 1 building, 2 residences. That's what an equation is that this is 1 giant house, okay? 1 giant building, okay? But it's a duplex, meaning that there are 2 residences, right? Here's what we're going to do. We're going to draw a line down the equal sign. That's going to be the shared wall, all right? That's the shared wall. Here's the deal. Variables are hermits. What's a hermit?
Those people that live in huts or something.
Not homeless people. You said people live in huts. What are hermits like? Seclusion. Hermits want to be alone. Hermits want to be alone. Does that make sense? Hermits want to be alone. They don't want anybody living in their house with them at all. They want to be alone. In this situation, here's the deal. Is the hermit happy here in this situation? No. There's a 4 in his house. He is not living alone. Does that make sense? He is not alone and he hates that. So then, the hermit's got to kick out everybody who's in his house. There's a 4 in his house. What is the 4 doing to the hermit? It's adding to him. Does that make sense? He's adding to him. So, what is the opposite? What could he do to get rid of this plus 4? Minus 4. We're going to minus 4, right? There's a plus 4 here. How would I get rid of that? He's going to minus 4. Now, at this very moment, if I stopped right here, What's happened to our scale?
This has
Whoop. Right? No good. So what do I have to do immediately? As soon as I put a -4 there, I need to put a -4 over here. Does that make sense? If I take away 4 rocks here, I got to take away 4 over here. I have to do it. As soon as that happens, just get used to that. Write down on both sides what you're going to do to both sides so that it stays balanced. Now, what is +4 minus 4? What does that equal? 0. Now, I could put x plus 0 down here. That would be redundant. Do I need to put +0? No. So what I'm going to do is this. I'm going to simply cross out those 4s because the reason why I subtracted 4 was to get him out of the house anyway. That leaves me now with x on this side of the house, right? On this side of the structure, in his own duplex. The equal sign stays on the wall, right? The equal sign stays on the shared wall. And now, if you were to take a snapshot of this picture right here, just take a snapshot, what does that look like? Doesn't that look like 6 minus 4, just like that? Just like you'd see in kindergarten?
Yes.
Right? If you took a picture of that, oh my goodness gracious, you have a perfect little question there. What is 6 minus 4?
2.
And we're done because the variable is happy. He's alone, right? X is 2. Let's try another one. This time it'll be a little bit weirder. M minus 6 equals 5. Okay, now here's the deal. Watch this. Watch. The first thing we always do is we have to create the duplex by line down the equal sign. That's creating the shared wall. Does that make sense? In this situation, is the hermit or is the variable happy?
no.
Why not?
Because he has a -6 there.
The answer is because he's not alone, right? He's not alone. Who's in the house with him? There's a 6 there. There's a 6 with him. What's the 6 doing to him? No. What's the 6 doing to him? It's subtracting from him. Does that make sense? There's a 6 in there, and he's subtracting from him. The hermit hates that. He wants this guy out of here. What does he have to do to get rid of -6? How would you get rid of -6? Add 6. As soon as I add 6 to one side, what do I have to do? Add 6 to the other side. Right? What happens to these guys? They become 0, so I can just cross them out. They're gone. That leaves me with M equals, what is 5 plus 6? 11. How can I know if I got this right? What can I do to find out if I actually got this right? Kyla?
Well, besides doing that way into the actual equation itself.
Now what you do, I'll show you, is you take this. You're telling me that the variable, the unknown, is 11. Let's go up and see if that's true. Let's plug it into the original question and see if it works. So the original question was M minus 6 equals 5. Instead of M, I'm saying that M and 11 are identical. That's what I'm saying, right? I've solved it and I figured out that M is equal to 11, which means that if M is the same as 11, then wherever I see an M, I can put an 11, right? So instead of M minus 6 equals 5, I'm going to, in parentheses, do 11 minus 6 equals 5. What is 11 minus 6? 5. We did it right. Does that make sense? Because 5 equals 5, and we know we got it right. That's how you find out if you got it right. Now listen, I am very well aware this is super simple, right? And you could do this in your head all day long. Don't care. You're showing your work just like this on every question that you do. Yes?
Do you want us to check too?
No. I mean, you can do that on your own, but there's no procedure for me, you showing that and showing me. That's fine. But you can go back up and you can look and see whether or not you got it right.
So we're supposed to do.
Okay, so let's look at, let's do a couple that are a little bit weird. Okay, those are the really, really, really simple ones. Now I'm just going to throw a few curveballs at you that shouldn't bother you at all. What if I have this? W plus a -4 equals 10. Okay, so let's look at this. Everybody up here, first of all, let's practice this. You should be writing these down. So that you need to have at least a couple of these down so that you'll know exactly and you'll remember exactly how to do it. So I would do this on your homework page because I'm going to force you to do it on your homework page anyway. At least now you'll have a couple that are done perfect. Yes?
This can also be used as references just in case we forget.
Right. So here we go. You're writing this down, right? Here's the question. What's the first thing that we do anytime we see an equation?
Line.
The line down the equal sign. That's what we do. Mr. M should have shown you how to do this, right? Did he do it with you like this, with a line down the equal sign? Right? Yeah. Guess who taught me how to do this? Guess who was my algebra teacher? Mr. M. That would be 29 years ago.
Woo!
So, anyway, here we go. The line down the equal sign, that creates the shared wall, right? Now you have to look and go, okay, is the variable happy? No. Who's in the house with him? Here's the deal. What you need to do is this. Before anything else happens, what do you see? A red flag. That's right. Yeah, I see that big giant red flag there. I've got a plus and a minus sign touching. Take care of that. Rewrite this without the red flag. When I see that plus minus, what does that become? A minus sign, a giant minus sign. So I'm going to rewrite it. W minus 4 equals 10. You've got to do that. You should write that down, right? You're all copying this exactly the way I have it, so that you have a reference. Right? Now that I've done this, is the variable happy? He's happy? Why isn't he happy? What's that variable? What's his most important thing?
He's not alone.
He's not alone. Right? He's not alone. And why? Who's in their house with him?
-4.
The -4. Well, how is he going to get rid of that -4?
+4 and then
Add 4. What happens here? They're gone, right? That's why I added 4, was to make them be gone. W equals, what is 10 plus 4? 14. Now, what can I do just really quick to figure out if I got it right? Go plug it in. Is 14 up here, is 14 minus 4, 10? Is 14, if I replace the W with 14, I've said that W equals 14. Is 14 minus 4, 10?
yes.
Then we got it right. Right? Question.
So, on the actual assignment, we don't have to do that check.
Here's the thing. You're asking me whether you have to check. Every time you do it, you should check. Right? I mean, how long does it take? How long did it take for me to go, okay, I'll go look up there and go, is 14 minus 4, 10? How long does that take? 1 second? 2? You should always do that. That's math. Good math students always do the quick little, like, am I right? Am I even in the ballpark here? Does that make sense? That's what you do. All right, let's do a couple more. Let's do some big ones here. I'm going to give you a big one that you can't do in your head.
Write it down.
Oh yeah, practice this for me. Try it for me. Just because it's big and ugly, the rules don't change. You just keep doing it. You do go through the steps. All right, here we go. Paying attention, looking now, right now. First thing we do. Line down the equal sign. Then you ask yourself, is the variable happy? No, why not? Because he's not alone. Who's with him?
698 people.
What is the 698 doing in his house? What's happening in there? It's adding to him, right? It's adding to him. How do I get rid of that 698 then? Minus 698 minus 698. M equals. Do you see how it's set up just like a regular problem? I mean, like a first or second grade subtraction problem. I'm going to go over here and go 3. That's a 3. This becomes a 9 for 343. Variable's happy now. He's alone. He kicked out everybody out of his house. How many of you got 343? Were you about to get 343?
I might have gotten 343, but then I added it together, and then I added the 343 with the 698.
Why? Where are you getting that from? How would you possibly do that?
No, to check it.
Oh, right. Yeah, 343 plus 698 should equal 1,041.
Yeah, and then I got that wrong. So I erased it.
Okay. Anyway, one last thing. I'm going to do something and I want to see if you guys can handle this. Okay, you ready? You're watching now, ready? Line down the equal sign. Nothing changes. Is the variable happy? No. Okay, why not? He's not alone. Who's with him? 7. How do I get rid of that plus 7? Minus 7, minus 7. Notice that nothing's changing. What's the weird part about this? It's on the other side, right? He's on the right side of the duplex. So we're going to fix that here in a second. They're gone. That leaves me with y equals 6. Here's the deal. In 7th grade, to start here, there's nothing wrong with this. 6 equals y. There's nothing wrong with that. But the variable at the end, once he's alone, what's the most important thing to the variable? That he's alone. He is alone now. But now that he's alone, he would prefer to be in the left house. Does that make sense? He would prefer to be in the left house. So you want to solve this thing until he's alone. That's the key. And then once we're down to okay, he's alone. Whew, switch him back. He wants to be on the left. Y equals 6. Does that make sense? Okay. Most important thing though, he wants to be alone. But then once he's alone, okay, good. Now he'll switch houses with the person. He wants to be on the left. Yeah.
In the answer column, would you like us to write y?
I want you to put variable equals number. Yeah, that's the whole deal. I want variable equals number. Everything else you guys should be able to do just fine. I am going to do this. I'm going to have you do 1 through 9 all. That's it on page 89. 1 through 9 all. What do you think the most important part about this whole assignment is? That you show your work my way. Each one that you do, you have to show your work my way. Line down the equal sign, put them plus or minus, whatever it is, cut it in half. I have given you samples here. There's absolutely no excuse for you not to show your work on every one. Do you think that I'm aware that you could do these in your head? Yes. Absolutely. That's not the point. You show your work so that you get used to doing them, so that you know how to do them when they get much, much more difficult. Yes? No. Your work is on the left, right? Your work is over here. Here's your paper. There's the answer column. This is where your work is. Right? In your answer column, all it should say is x equals 2 or m equals -4.